24-inch clearance is not acceptable for the front of the 50 kilovolt-ampere UPS unit. According to the National Electrical Code, known as the NEC and the Institute of Electrical and Electronics Engineers Standard 1584, specific minimum clearances are required around the UPS system to ensure safety, proper ventilation, and ease of maintenance. These clearances vary depending on the location relative to the UPS unit. For the front of the UPS system, a minimum clearance of 36 inches, which is approximately 914 millimeters, is required. For the sides of the UPS system, a minimum clearance of 24 inches, which is approximately 610 millimeters, is typically sufficient. For the rear of the UPS system, the most substantial clearance is needed, requiring a minimum of 48 inches, which is approximately 1219 millimeters. These clearances serve several critical purposes. Firstly, adequate ventilation is crucial for the UPS system to prevent overheating. UPS units generate heat during operation, and insufficient ventilation can lead to component failure and reduced lifespan. The specified clearances allow for proper airflow around the unit, dissipating heat and maintaining optimal operating temperatures. Secondly, these clearances are essential for maintenance and repairs. UPS systems require periodic maintenance to ensure their reliability and performance. The clearances provide sufficient space for technicians to access the unit, perform inspections, replace components, and conduct repairs safely and efficiently. Adequate space reduces the risk of accidents and injuries during maintenance activities. Thirdly, the clearances are vital for preventing electrical hazards. UPS systems operate at high voltages and currents, and improper clearances can increase the risk of electrical shock or arc flash incidents. The specified clearances provide a safe working distance for personnel and prevent accidental contact with energized parts. Moreover, in this specific scenario, the UPS unit includes a breaker distribution section. This addition may necessitate even greater clearance to facilitate secure access and seamless operation of the breakers. Breaker distribution sections commonly need additional space to enable the manipulation of breakers, execute essential switching operations, and guarantee secure maintenance procedures. Adhering to these clearance standards is not merely a matter of compliance, it is a fundamental aspect of ensuring the safety and reliability of the UPS system. By providing adequate space around the unit, potential hazards are minimized, maintenance is simplified, and the lifespan of the equipment is extended. Therefore, it is highly recommended to increase the clearance around the UPS system to meet the minimum requirements specified in the NEC and IEEE 1584. This proactive measure will significantly enhance the safety and reliability of the UPS system, aligning it with industry best practices and regulatory standards. Failure to adhere to these clearance requirements can have serious consequences. Firstly, it can void the warranty of the UPS system. Manufacturers typically specify minimum clearance requirements in their product documentation, and failure to comply with these requirements can invalidate the warranty, leaving the owner responsible for any repair or replacement costs. Secondly, non-compliance can lead to code violations and potential fines. Electrical inspectors regularly check for compliance with the NEC and other applicable codes, and violations can result in costly fines and penalties. Thirdly, and most importantly, inadequate clearances can increase the risk of accidents and injuries. Electrical shocks, arc flash incidents, and other hazards can occur if personnel do not have sufficient space to work safely around the UPS system. Such incidents can result in serious injuries or even fatalities. In summary, maintaining adequate clearances around a UPS system is a critical aspect of electrical safety and equipment reliability. By adhering to the minimum requirements specified in the NEC and IEEE 1584, the risk of accidents, injuries, and equipment failure can be significantly reduced. The front of the unit requires 36 inches, the sides require 24 inches, and the rear requires 48 inches. These clearances provide adequate ventilation, allow for safe maintenance and repairs, and prevent electrical hazards. Therefore, it is essential to prioritize compliance with these standards to ensure the safety of personnel and the longevity of the UPS system. To elaborate further on the NEC and IEEE 1584 standards, it is important to understand their specific requirements and how they apply to UPS systems. The NEC, published by the National Fire Protection Association, is a widely adopted code that sets the standard for safe electrical installations in the United States. It provides detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical systems. Article 110.26 of the NEC specifically addresses working space about electrical equipment operating at 600 volts, nominal, or less to ground. This article specifies minimum clearances for access and working space around electrical equipment, including UPS systems. The required clearances vary depending on the voltage level and the presence of exposed live parts. IEEE Standard 1584, titled IEEE Guide for Performing Arc Flash Hazard Calculations, provides guidance on assessing and mitigating arc flash hazards in electrical systems. Arc flash is a dangerous phenomenon that can occur when a short circuit creates an explosive release of energy, causing severe burns, injuries, and even fatalities. IEEE 1584 provides methods for calculating the incident energy of an arc flash and determining the appropriate personal protective equipment, known as PPE, required to protect workers from the hazard. While IEEE 1584 does not directly specify minimum clearances for UPS systems, it emphasizes the importance of providing adequate working space to reduce the risk of arc flash incidents. The standard recommends that electrical equipment be installed in a manner that allows for safe operation and maintenance, with sufficient space for workers to perform tasks without being exposed to arc flash hazards. In addition to the NEC and IEEE 1584, other industry standards and best practices may also apply to UPS system installations. For example, some manufacturers may specify additional clearance requirements in their product documentation to ensure proper ventilation and cooling. It is important to consult all applicable standards and guidelines to ensure that the UPS system is installed in a safe and compliant manner. When determining the appropriate clearances for a UPS system, several factors should be considered. Firstly, the size and configuration of the UPS unit will influence the required clearances. Larger UPS systems typically require more space for ventilation and maintenance. Secondly, the voltage level of the UPS system will affect the required working space. Higher voltage systems generally require greater clearances to reduce the risk of electrical hazards. Thirdly, the presence of other equipment or obstructions in the vicinity of the UPS system may necessitate additional clearance. It is important to ensure that there is sufficient space to access the UPS system for maintenance and repairs without being hindered by other equipment. Fourthly, the specific tasks that will be performed on the UPS system should be considered. If the UPS system requires frequent maintenance or adjustments, it may be necessary to provide additional clearance to facilitate these activities. For example, if the UPS system has a battery bank that requires periodic replacement, sufficient space should be provided to allow for easy access to the batteries. Furthermore, the skill level and training of the personnel who will be working on the UPS system should be taken into account. If the personnel are not highly experienced or trained, it may be necessary to provide additional clearance to reduce the risk of errors or accidents. Ultimately, the goal is to provide a safe and ergonomic working environment that minimizes the risk of injuries and ensures the reliable operation of the UPS system. In some cases, it may be necessary to exceed the minimum clearance requirements specified in the NEC and IEEE 1584 to achieve this goal. For instance, if the UPS system is located in a confined space, it may be necessary to provide additional ventilation to prevent overheating. Similarly, if the UPS system is located in an area with high traffic, it may be necessary to provide additional protection to prevent accidental damage. When increasing the clearance around a UPS system, it is important to consider the impact on other equipment and systems. Adding space to one area may require adjustments to other areas, such as rearranging equipment or rerouting cables. It is essential to plan the changes carefully and ensure that they do not create new hazards or compromise the functionality of other systems. In addition to physical clearances, it is also important to consider other safety measures when working with UPS systems. These measures may include wearing appropriate PPE, such as safety glasses, gloves, and arc-rated clothing, using insulated tools, and following lockout/tagout procedures to de-energize the UPS system before performing maintenance or repairs. Lockout/tagout procedures are designed to prevent accidental energization of electrical equipment during maintenance or repairs. These procedures involve disconnecting the power supply to the equipment and placing a lock and tag on a disconnect switch to prevent it from being turned on. Only authorized personnel are allowed to remove the lock and tag, ensuring that the equipment remains de-energized until the work is completed. Regular inspections and maintenance are also crucial for ensuring the safety and reliability of UPS systems. These inspections should include checking for loose connections, damaged components, and signs of overheating. Any issues that are identified should be addressed promptly to prevent them from escalating into more serious problems. Furthermore, it is important to train personnel on the proper operation and maintenance of UPS systems. This training should cover topics such as safety procedures, troubleshooting techniques, and emergency response protocols. Properly trained personnel are more likely to identify potential hazards and take appropriate action to prevent accidents and equipment failures. In conclusion, maintaining adequate clearances around a UPS system is a multifaceted process that requires careful consideration of various factors. By adhering to the minimum requirements specified in the NEC and IEEE 1584, and by implementing other safety measures such as wearing appropriate PPE, using insulated tools, and following lockout/tagout procedures, the risk of accidents, injuries, and equipment failures can be significantly reduced. Regular inspections, maintenance, and training are also essential for ensuring the long-term safety and reliability of UPS systems. It is recommended to consult with qualified electrical professionals to determine the appropriate clearances and safety measures for a specific UPS system installation. These professionals can assess the specific conditions of the site and provide tailored recommendations to ensure compliance with all applicable standards and regulations. Ignoring the clearance requirements around a UPS system can lead to several negative outcomes. Firstly, it can create a hazardous working environment for personnel who need to access the equipment for maintenance or repairs. Limited space can make it difficult to maneuver safely, increasing the risk of accidental contact with energized parts. Secondly, inadequate clearances can restrict airflow around the UPS system, leading to overheating and reduced performance. Over time, this can shorten the lifespan of the equipment and increase the likelihood of failures. Thirdly, non-compliance with clearance requirements can result in violations of electrical codes and regulations, leading to fines and penalties. Electrical inspectors are responsible for enforcing these codes, and they will typically issue warnings or citations for any violations that are found. Fourthly, inadequate clearances can void the warranty of the UPS system, leaving the owner responsible for any repair or replacement costs. Manufacturers often specify minimum clearance requirements in their product documentation, and failure to comply with these requirements can invalidate the warranty. Finally, and perhaps most importantly, inadequate clearances can increase the risk of electrical accidents such as shocks, arc flashes, and fires. These accidents can cause serious injuries or even fatalities, as well as significant property damage. Therefore, it is essential to prioritize compliance with clearance requirements to protect the safety of personnel and prevent costly accidents. To further illustrate the importance of clearance requirements, consider a hypothetical scenario. Imagine a UPS system that is installed in a small, crowded room with minimal clearance around it. The room is poorly ventilated, and the UPS system is constantly running hot. Over time, the components inside the UPS system begin to degrade due to the excessive heat. One day, a technician is called in to perform maintenance on the UPS system. However, due to the limited space, the technician has difficulty accessing the equipment safely. While trying to maneuver around the UPS system, the technician accidentally touches an energized part and receives an electrical shock. The technician is injured and the UPS system is damaged. This scenario highlights the importance of providing adequate clearances around UPS systems. In this case, the limited space, poor ventilation, and inadequate safety measures all contributed to the accident. By following the clearance requirements specified in the NEC and IEEE 1584, and by implementing other safety measures, this accident could have been prevented. To ensure compliance with clearance requirements, it is important to follow a systematic approach. Firstly, review the product documentation for the UPS system to determine the manufacturer's recommended clearances. Secondly, consult the NEC and IEEE 1584 to determine the minimum clearances required by code. Thirdly, assess the specific conditions of the installation site, taking into account factors such as the size and configuration of the UPS system, the voltage level, the presence of other equipment, and the skill level of personnel. Fourthly, develop a plan for providing adequate clearances, taking into account any constraints or limitations of the site. Fifthly, implement a plan, making any necessary adjustments to the layout of the equipment or the structure of the building. Sixthly, inspect the installation to ensure that it complies with all applicable requirements. Seventhly, document the installation, including the clearances that were provided and the safety measures that were implemented. Finally, periodically review the installation to ensure that it continues to comply with the requirements. In addition to physical clearances, it is also important to consider the accessibility of the UPS system for maintenance and repairs. The UPS system should be located in an area that is easily accessible to technicians with sufficient space to maneuver tools and equipment. The area should be well lit and free of obstructions. The UPS system should also be located in an area that is protected from environmental hazards such as moisture, dust, and extreme temperatures. These hazards can damage the UPS system and reduce its performance. To protect the UPS system from these hazards, it may be necessary to install additional equipment such as air conditioners, dehumidifiers, and dust filters. Furthermore, it is important to consider the security of the UPS system. The UPS system should be located in an area that is protected from unauthorized access. This may involve installing security cameras, access control systems, and other security measures. The UPS system should also be located in an area that is protected from vandalism and theft. These precautions can help to prevent damage to the UPS system and ensure its continued operation. In NEC, specifically Article 110.26, details workspace requirements around electrical equipment. Condition 1 specifies the working space where there are exposed live parts on one side and no live or grounded parts on the other side of the working space, or where there are exposed live parts on both sides effectively protected by insulated materials, such as rubber. Condition 2 specifies the working space where there are exposed live parts on one side and grounded parts on the other side of the working space. Condition 3 specifies the working space where there are exposed live parts on both sides of the working space, not guarded as provided in Condition 1, with the operator between. It is important to note that for 150 volts to ground or less, the minimum clear distance for Condition 1 is 3 feet, or 914 millimeters. For 151 to 600 volts, the minimum clear distance is also 3 feet, or 914 millimeters. For Condition 2 with 150 volts to ground or less, the minimum clear distance is 3 feet, or 914 millimeters. For 151 to 600 volts, the minimum clear distance is 3 feet, or 914 millimeters. For Condition 3 with 151 to 600 volts, the minimum clear distance is 4 feet, or 1219 millimeters. These distances are measured from the live parts to the nearest grounded surface or to the nearest live part on the opposite side. The NEC also specifies minimum headroom requirements for working spaces. The minimum headroom is 6½ feet, or 1.98 meters, unless the equipment requires a greater height. The NEC requires that working spaces be adequately illuminated. The minimum illumination level is 10-foot candles, or 108 lux, measured at the working surface. The NEC also requires that working spaces be kept clear and unobstructed. There should be no storage of materials or equipment in the working space. The working space should be large enough to allow workers to perform their tasks safely and efficiently. To further elaborate, consider the specific scenario of a 50 kilovolt-ampere UPS unit. The size and configuration of this unit will influence the required clearances. Generally, larger UPS units require more space for ventilation and maintenance. The manufacturer's documentation should provide specific clearance recommendations for this particular model. The voltage level of the UPS system is also a critical factor. If the UPS system operates at 480 volts, the minimum clear distance for condition 3 would be 4 feet or 1219 millimeters as specified in the NEC. However, if the UPS system operates at a lower voltage such as 208 volts or 120 volts, the minimum clear distance may be less. The presence of a breaker distribution section in the UPS unit also affects the clearance requirements. The breaker distribution section typically requires additional space for safe access and operation. The NEC requires that electrical equipment be installed in a manner that allows for safe operation and maintenance, with sufficient space for workers to perform tasks without being exposed to electrical hazards. In addition to the NEC and IEEE 1584, other industry standards and best practices may also apply to the UPS system installation. For example, some manufacturers may specify additional clearance requirements in their product documentation to ensure proper ventilation and cooling. It is essential to consult all applicable standards and guidelines to ensure that the UPS system is installed in a safe and compliant manner. Proper ventilation is crucial for preventing overheating of the UPS system. Insufficient ventilation can lead to component failure and reduced lifespan. The specified clearances allow for proper airflow around the unit, dissipating heat and maintaining optimal operating temperatures. The clearances also provide sufficient space for technicians to access the unit, perform inspections, replace components, and conduct repairs safely and efficiently. Adequate space reduces the risk of accidents and injuries during maintenance activities. UPS systems operate at high voltages and currents, and improper clearances can increase the risk of electrical shock or arc flash incidents. The specified clearances provide a safe working distance for personnel and prevent accidental contact with energized parts. In conclusion, maintaining adequate clearances around a 50 kilovolt-ampere UPS unit is a critical aspect of electrical safety and equipment reliability. By adhering to the minimum requirements specified in the NEC and IEEE 1584, the risk of accidents, injuries, and equipment failure can be significantly reduced. The front of the unit requires 36 inches, the sides require 24 inches, and the rear requires 48 inches. These clearances provide adequate ventilation, allow for safe maintenance and repairs, and prevent electrical hazards.